And let's show the viewing audience what we're talking about. I'm holding what looks like a normal little spring in my hand, but what is this really?
Well, that's actually a metal spring, and instead of being made from normal steel, it's a special alloy that's been processed in a special way. That's a shape memory alloy, and it's then coiled into the spring.
So now we're going to show what happens, because I can deform this. I'm going to pull it all apart.
Yep, and don't worry like a regular spring about making it twisted.
Twist it all up. Now watch this closely, folks, and keep a close eye on it. I'm going to drop it in this hot water, and it's going to change instantly. Bang. I hope you see that right now. Let me try to fish this out of this beaker and show everybody that this thing, and it's easy to hold, it's not that hot, it's gone back to being a normal little spring again.
And the key is, John, we can do that over 1 million times with no change, and it transforms at a very well-controlled temperature. And so I would say just do it again.
I'll do it again. So what we're saying is, this could be in the car, and now you heat it up, and it's going to pull. Right. It's going to pull back. And so let's, again, just watch this thing, just how instantaneous, kaboom, it's back there again.
So all the kinds of things that we would want to move, whether it's by a lever, with a motor, we can now do just by heating up this material.
And a whole lot less mass and whatnot.
And lower cost, lower weight, very little energy consumption. And in particular, we can package things we couldn't fit a motor into.
We're going to show you what some of these smart materials can do. So let's start with, what are we looking at here, and what does this thing do?
Well, you know all the emphasis that we have on fuel economy today, and you can do all the things we're doing in the propulsion engine and electrification of the vehicle. In the end, I have to move the vehicle, and its fuel economy depends on weight, rolling resistance, and aerodynamics. So one of the things we'd like to do to control aerodynamics dynamically is open and close louvers in front of the radiator. Doing that with smart materials, let me show you. And just watch the grill open. And we can close it dynamically.
And the point, there's no motor here, there's no hydraulics. This is just like the spring demonstration we gave.
And it's low cost, John. And that's the real key here.
That's unbelievable. And let's move down here. The red one, to me, I don't know if it looks like that to the viewing audience, but what we're looking at is the rear spoiler on the car.
Right. And once again, there's a desire both for styling and for control of fuel economy to have it deploy dynamically. So once again, no motor involved. And I think you know there are several of these that do move in the industry today. Complex motor mechanisms. This is using that simple wire we showed you before. Fast deploy and fast undeploy when we're ready for that. And so again, it's the ability to do it without adding much weight. High reliability for warranty. So that's the real emphasis here.
I find this very exciting, because this could be tied into a speed sensor in the car. So once you hit a given speed, you would know that you should pop the spoiler up, or heavy braking situations. You could tell this thing when to deploy.
Sure, and it's the same thing with the louver. We do it as a function of the required cooling of the vehicle. So the whole key now is we have all the sensors on the vehicle. We've really deployed them. We've got the computing power. Now we're finding a way for low-cost actuation.
Well, let's take a look at this last one that we've got right here.
Well, let me ask you to take the key fob. So imagine you're approaching the vehicle. You want to go in, and you're someone who likes to use the grab handle.
So this would be like the A-pillar of a car.
That's right.
Or maybe the roof rail of a car.
That's right, and you can't quite reach it. So very simple device.
Okay, so I've got a key fob in my hand. I'm going to hit the unlock, and kaboom.
So now it presents itself to the person.
So I don't have to go try to peel the thing off the A-pillar. It's right there for me.
And the key is, you know, we have all sorts of head impact and safety criterion. Packaging a motor to accomplish this has some challenges. We simply have a device back here that takes advantage of this resistance heating of the wire, and we can do this. And now you can imagine, and this is the real key, John. I'm showing you the stuff now that's already in the production pipeline. You have to see the stuff we have in the lab, the next generation things, where we're not just replacing things we could do with motors. We're starting applications that you can't even do with a motor.
Well, Dr. Alan Taub, this is extremely exciting for me. We're looking at a breakthrough. We're looking at the future of the automotive industry. Thanks so much for coming on Autoline Detroit, talking all about it, and bringing these props along with you.
Oh, thanks, John. I really feel like Mr. Wizard today.
That's great.